Assalamualaikum and good morning to my examiner, Dr. FAZLENA. Before I start my presentation, my name is SITI LIYANA binti Muhammad MOKHALDIN. Today, I will present my research entitled A Review of Carbon Dioxide Capture Using Carbon Material and Zinc to Cyclen. Let me introduce the outline first. The presentation will be given in 5 parts, which are background, problem statement, objective, research scope, review, and conclusion of my research. In the first part, I will introduce two terms, activated carbon and zinc to cyclen. Activated carbon is commonly applied in industrial activities such as environmental management, wastewater management, gas filter, and so forth. The most important characteristic of an activated carbon is the surface area and yield, which is strongly affected by its preparatory condition. Zinc to cyclen is a mimic enzyme of carbonic anhydrase. Usually, carbonic anhydrase is an enzyme that is found in plants and animals to catalyze the hydration of carbon dioxide. Zinc cyclen is an ideal substitution of carbonic anhydrase since it has high catalytic activity and stability. Next, I will talk about the problem statement of my research. Greenhouse emissions have been a great concern because of global warming. According to research, 40% of the world's carbon dioxide emissions are from power plants and are expected to grow to 60%. Carbon capture technology is one way to reduce the carbon dioxide emission into the atmosphere. My review focused on the post-combustion because it can easily retrofit into existing plant without changing the basic combustion technology. Next, the reason why my review focused on absorption study is because of the high cost of absorption method. Even though absorption capacity is low, it can be increased by modification on the carbon material. The objective of my review is to review the effect of modification of activated carbon on carbon dioxide absorption and to review the carbon dioxide adsorption performance using activated carbon integrated with zinc cyclen in carbon dioxide capture. Next, my research scope is the study of adsorption by using a mimic enzyme in the carbon dioxide hydration and the effect of modification on the characteristic of activated carbon and the performance of the activated carbon during carbon dioxide adsorption. For the next part, I will talk about method to modify activated carbon. The activation of carbon material can be done through physical or chemical activation. Chemical activation is a one-step process where activation can be conducted either by impregnating or physically mixing the chemical agent by dehydrating. Washing can be done either by using sodium hydroxide, water, or heat treatment. Meanwhile, physical activation is a two-step process, which is carbonization and physical activation using steam, air, or carbon dioxide. The chemical activation usually takes place at temperature lower than temperature used in physical activation. Then, the activated carbon undergo analysis such as carbon yield, BET surface area, adsorption isotherm, SEM analysis, and pH value. After analysis, the CO2 is hydrated using zinc cyclen. Charcoal yield shows the loss of raw material during activation phase, which symbolizes the changes of the pore inside the material. From the table, the charcoal yield decreased as the activation temperature increased. According to a study by Huang, high activation temperature allows easier release of volatile substance forming micropores, thus increasing the BET specific surface. Typically, the carbon yield of chemical activation are higher than physical one. A proper selection of activation agent and impregnation ratio is important to produce a high surface area of activated carbon for an adsorption process. Also, it is important for the chemical agent to be safe for the environment. Potassium hydroxide and sodium hydroxide is a strong base which is hazardous, expensive, and corrosive, while zinc chloride is not only harmful to the environment but could cause unwanted problems during disposal. According to Huang, pH value increases simultaneously with activation temperature and activation time. The same morphology of activated carbon prepared under nitrogen has the smoother surface because oxygen is eliminated in the system by nitrogen stream. Adsorption capacity of activated carbon is dependent on its specific surface area, pore volume, and pore size development. The hydration process of carbon dioxide, which is conversion of carbon dioxide into bicarbonate ion using zinc cyclen, occurs in aqueous solution. The hydration of carbon dioxide is depending on the pH. From a study, show the rate of hydration of carbon dioxide increase with increasing pH. Finally, I would like to conclude my presentation. First, carbonization and pretreatment of the activated carbon helps to remove the impurity of activated carbon before and after activation respectively for a better carbon dioxide absorption. Secondly, potassium carbonate is a potential chemical agent. Lastly, zinc cyclen acts as a mimic enzyme that assists catalysis of carbon dioxide hydration. The rate of hydration performs well in basic aqueous solution. And that is the end of my presentation. I would like to thank you for your time and attention today. I also want to express my gratitude to my research project supervisor for the support, guide, and knowledge that she has given.